today we're gonna start with discussing about chemistry for part 1 for class 11. As you know, we had even though started with the same, and that is we had covered up the many of the topic related to the part 1 for chemistry class 11 we had done. This is your unit 8 which we had end up with in the last classes, but some of the question has been left, so we'll discuss that in this class. But before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. In terms of chemistry, if I'm going ahead, yes, this has been the class 11th chemistry part 2, and this is your class 9 where we'll discuss some of the questions related to the redox reaction, and that we had even though solved some of the question, but some of the question I told you that is been important and you have to be practice about it. So starting with the question here you have to assign oxidation number to the underlined element in each of the following species, where we have NaH2PO4 where P is being underlined, NaHSO4 S is underlined, H4P2O7 P is underlined, K2MnO4 where Mn is underlined, CaO2 where O is underlined, NaBH4 where B is underlined here, H2S2O7 that is S is underlined, KAlSO4 whole twice dot for 12H2O where S is underlined. Now then the question is, what are the oxidation number of the underlined elements in each of the following, and how do you rationalize your result as well? So the options for the same, we have Ki3 where I is underlined, H2S4O6 S is underlined, Fe3O4 Fe is underlined, CH3 CH2OH where both C has been underlined, and CH3 COOH where both C is being underlined. Now coming to another one, there you have to justify the following reaction that are redox reaction. So CuO solid plus H2 gas, that gives Cu solid plus H2O in the form of gas. The another equation, Fe2O3 solid plus 3CO gas, that gives 2Fe solid plus 3CO2 gas. Another one, 4BCl3 gas plus 3LiAlH4 solid, that gives 2B2H6 gas plus 3LiCl solid plus 3AlCl3 solid. Another one, 2K solid plus F2 gas gives 2K plus 1, 2K plus F minus solid. Another is 4NH3 gas plus 5O2 gas gives 4NO gas plus 6H2O gas. Another question, fluorine reacts with ice and results in change to H2O in solid plus F2 gas, that gives HF gas and HOF in the form of gas. You have to justify the reaction in the redox reaction. Another question, that is you have to calculate the oxidation number of sulfur, chromium and nitrogen in H2SO4, Cr2O7 2 minus and NO3 minus. Suggest structures of these compound count for the fallacy. Another question we have, write the formulas for the following compound, where mercury second chloride, nickel second sulfate, tin 4 oxide, thallium first sulfate, iron third sulfate, chromium third oxide. Another question, suggest a list of the substance where the carbon can exhibit oxidation state from -4 to +4 and nitrogen from -3 to +5. Then the question we have, while sulfur dioxide and hydrogen peroxide can react as oxidizing as well as a reducing agent in their reaction, ozone and nitric acid act only as oxidant. Why? Another question, consider the reaction 6CO2 gas plus 6H2O liquid will give 6C6H12O6 aqueous plus 6O2 gas. Another we have reaction O3 gas plus H2O2 liquid gives H2O liquid plus 2O2 gas. Why it is more appropriate to write these reactions as the another is 6CO2 gas plus 12H2O liquid gives you C6H12O6 aqueous plus 6H2O liquid plus 6O2 gas. O3 gas plus H2O2 liquid gives you H2O liquid plus O2 gas plus O2 gas. With that, also suggest a technique to investigate the path of the above A and B in the redox reaction that you have to solve. Now, another question we have here is the compound AgF2 is unstable compound. However, it is formed that the compound act as a very strong oxidizing agent. Why? Another is whenever a reaction between an oxidizing agent and a reducing agent is carried out and a compound of lower oxidation state is formed, if the reducing agent is in the excess and a compound of higher oxidation state is formed, if the oxidizing agent is in excess, justify the statement giving 3 illustrations. Another question, how do you count for the following observation? The first is, though alkaline potassium permanganate and acidic potassium permanganate both are used as oxidant, yet in the manufacture of benzoic acid from toluene, we use alcoholic potassium permanganate as an oxidant. Why? Write a balanced redox reactions for the equation. The another question for the same. When concentrated sulfuric acid is added to an inorganic mixture containing a chloride, we get colorless, pungent smelling gas HCl. But if the mixture contains bromide, then we get red vapor of bromine. Why? Now we go for another question here. Another question we talk here about is to identify the substance that oxidize reduced oxidizing agent and reducing agent for each of the following reaction, where 2 AgBr in solid plus C6H6O2 aqueous will give you 2 Ag solid plus 2 HBr aqueous plus C6H4O2 aqueous. Another is SCHO in that first plus 2 AgNH3 twice aqueous plus 3 OH minus aqueous plus that will give you 2 Ag solid plus HCOO plus aqueous plus 2 NH3 aqueous plus 2 H2O liquid. Another is SCHO first plus 2 Cu2 plus aqueous plus 5 OH minus aqueous will give you Cu2O solid plus HCCOO minus aqueous and plus 3H2O liquid. N2H4 liquid plus 2H2O2 liquid that will give you N2 gas plus 4H2O gas. Pb solid plus PbO2 solid plus 2H2SO4 aqueous will give you 2PbSO4 solid plus 2H2O liquid. Now there are many equations related to it. Consider the reaction 2S2O3 2 minus aqueous plus I2 solid will give you S4O6 2 minus aqueous plus 2I minus aqueous. S2O3 2 minus aqueous that we have plus 2Br2I liquid plus 5H2O liquid will give you 2SO4 2 minus aqueous plus 4Br minus aqueous. So 10 that is H plus aqueous. Why does the same reductant thiosulfate react differently with iodine and bromine? Now another question is to justify giving reaction that among halogens, fluorine is the best oxidant and among hydroholic compound, hydroiodic acid is the best reductant. Why does the following reaction occurs, which is XeO6 4 minus aqueous plus 2F minus aqueous plus 6H plus aqueous, that gives XeO3 gas plus F2 gas plus 3H2O liquid. What conclusion about the compound Na4XeO6, of which XeO6 4 minus is a part that can be drawn from the reaction? The another equation we considered the following: H3PO2 aqueous plus 4AgNO3 aqueous plus 2H2O liquid will give you H3PO4 aqueous plus 4Ag solid plus 4HNO3 aqueous. Another is H3PO2 aqueous plus 2CuSO4 aqueous plus 2H2O liquid, that give H3PO4 aqueous plus 2Cu solid plus H2SO4 aqueous. C6H5CHO1 plus 2AgNH3 2 plus aqueous 3OH aqueous, and C6H5COO minus aqueous plus 2Ag solid plus 4NH3 aqueous plus 2H2O liquid. C6H5CHO first liquid plus we have 2Cu2 plus aqueous plus 5OH minus aqueous, that gives you no change observed. That is that the question has been demanding here. The another you have to consider the reactions and you have to answer accordingly. The other you have the what interferences do you draw about the behavior of Ag plus and Cu2 plus for these reactions. The another we talk about for the same is to balance the following redox reaction by ion electron method, which is MnO4 minus aqueous plus I minus aqueous will give MnO2 solid plus I2 solid in the basic medium. MnO4 minus aqueous plus SO2 gases, that will give them Mn2 plus aqueous plus HSO4 minus aqueous in acidic solution. Another is H2O2 aqueous plus Fe2 plus aqueous will give Fe3 plus aqueous plus H2O liquid in acidic solution. Another is Cr2O7 2 minus plus SO2 gases, they will give Cr3 plus aqueous plus SO4 2 minus aqueous in acidic solution. Now coming towards another one, which is balance the following equation in a basic medium by ion electron method and oxidation number method, and identify the oxidizing agent and the reducing agent. P4 solid plus OH minus aqueous will give PH3 gas plus HPO2 minus aqueous. N2H4 liquid plus ClO3 minus aqueous will give NO gas plus Cl minus gas. Cl2O7 gas plus H2O2 aqueous will give ClO2 minus aqueous plus O2 gas plus H plus. What sorts of information that can be drawn from the following reaction? Cn2 gas plus 2OH minus gas aqueous will give Cn minus aqueous plus CnO minus aqueous plus H2O liquid here. Now we talk about for the another one, which will be having what that is your another equation is the Mn3 plus ion is unstable in solution and undergo disproportions to give Mn2 plus MnO2 and H plus ion. Write a balanced ionic equation for the reaction. Consider the element Cs, Ne, I and F. Identify the element that exhibits only negative oxidation state. Identify the element that exhibits only positive oxidation state. Identify the element that exhibits both positive and negative oxidation state. And identify the element which exhibits neither the negative nor does the positive oxidation state. The another question we have: chlorine is used to purify drinking water. Excess of chlorine is harmful. The excess of chlorine is removed by treating with sulfur dioxide. Present a balance equation for the redox change taking place in water. Another, refer to the periodic table given in your book. Now answer the following question. You have to select the possible non-metal that can show disproportion reaction, and select 3 metals that can show disproportion reaction. Another one is an Ostward process for the manufacture of nitric acid. The first steps involves oxidations of ammonia gas by oxygen to give nitric acid, a nitric oxide gas, and steam. What is the maximum weight of nitric oxide that can be obtained, starting only with 10.00 gram of ammonia and 20.00 gram of oxygen. The another we have here, which is your Fe3 plus aqueous plus I minus aqueous, Ag plus aqueous and Cu solid, Fe3 plus aqueous and Cu solid, Ag solid and Fe3 plus aqueous, Br2 aqueous and Fe2 plus aqueous. Another question we have for the same is predict the product and electrolysis in each of the following, and an aqueous solutions of AgNO3 with silver electrodes. Another one is an aqueous solution AgNO3 with platinum electrodes, a dilute solutions of H2SO4 with platinum electrodes, and aqueous solutions of CuCl2 with platinum electrodes. Arrange the following metals in the order which they are, displace each other from the solutions of their salt, which is Al, Cu, Fe, Mgn, Zn. Give the standard electrode potential. K plus by K equals to minus 2.93 volt. Ag plus by Ag Gil equals to 0.80 volt. Hg 2 plus by Hg is 0.79 volt. Mg2 plus by Mg is minus 2.37 volt. Cr3 plus by Cr, so that will be minus 0.74. So here for the same, arrange these metals in their increasing order of reducing power. And the question is to depict the galvanic cell in which the reaction zinc solid plus 2Ag plus aqueous, that will give Zn 2 plus aqueous plus 2Ag solid take place. Further shows which of the electrodes negatively charged, and another is the carriers of the current in the cells and individual reactions at each electrode. That what we have. Now we go for the another one here, that is what we'll have to discuss, that is the another unit we'll start discussing about, which is unit 9. Unit 8 has been completed, unit 9 will start. That the name of the unit is your hydrogen. So let's get started with the same. Unit 9 is hydrogen. In the same way, in terms of hydrogen, so hydrogen, the most abundant element in the universe and the third most abundant on the surface of the globe, is being visualized as a major future sources of energy here. So with the same case for the unit 9, that is your hydrogen, we'll talk about. So here hydrogen has the simplest atomic structures among all the elements around us in nature. In atomic form, it consists of only one proton and one electron. However, in an elemented form, it exists as a diatomic H2 molecule and is called as dihydrogen. It forms more compound than any other element. Do you know that the global concern related to the energy that can be overcome to great extent by the use of hydrogen as a source of energy? In fact, hydrogen is of great industrial importance, as you will learn in this unit here. We'll discuss about some of the things related to it, which is positions of hydrogen in the periodic table, and that we'll discuss here in the detail about it. So let's go for the same. So here it has been position of hydrogen in the periodic table. So with the same here, that is, we'll discuss about positions of hydrogens in the periodic table. That hydrogen is the first element in the periodic table, as you know here. So that, however, its placement in the periodic table has been a subject of discussions in the past, and as you know that by now, that the element in the periodic table are arranged according to the electronic configuration, where hydrogen has electronic configuration 1s1. On one hand, in its electronic configuration is similar to the outer electronic configuration, which is ns1 of alkali metal, and which belongs to the first group of the periodic table. On the other hand, like halogens with ns2 and p5 configuration, with belonging to the 17th group of periodic table, it is shot by one electron to the corresponding noble gas configuration, which is helium 1s2 hydrogen. Therefore has resembles to alkali metal, which lose one electron to form unipositive ions, as well as with halogens, which gain one electron to form negative ions. Like alkali metals, hydrogen forms oxides, halides and sulfides. However, unlike alkali metal, it has been a very high ionization enthalpy and does not possess metallic characteristics under the normal condition. In fact, in terms of ionization enthalpy, hydrogen resembles more with halogens, which is delta I H of lithium is 520 kilojoule mole inverse. Fluorine is 1680 kilojoule mole inverse, and that of hydrogen is 1312 kilojoule mole inverse. Like halogens, it forms a diatomic molecules that combines with element to form hydrides and a large numbers of covalent compound. However, in terms of reactivity, it is very low as compared to the halogens as well. In spite of the fact that hydrogen, to the certain extent that resembles both with alkali metal and halogens, differs from them as well. And now the pertinent question arises as where should it be placed in the periodic table. Loss of electron from hydrogen atom that results in the nucleus, which is H plus of near about 1.5 into 10 to the power minus 3 pm size. This is extremely small as compared to the normal atomic and ionic sizes of 50 to 200 pm. As the consequences, H plus does not exist freely and is always associated with the other atom of molecules, that it is a unique and a behavior, and is therefore best placed separately in the periodic table. Now we talk about for the dihydrogen, that we go for it, and that even though we have to discuss the table as well. So yes, we'll go for the same. But here with this, we'll be going to discuss here in the detail about it. So we go for the table first, and then we'll discuss the rest of the things in the further way. So we'll discuss the dihydrogen, then isotopes of hydrogens, and so we'll go for dihydrogen here first. In terms of dihydrogen, dihydrogen is the most abundant element in the universe, where 70% of the total mass of the universe, and is a principal element in the solar atmosphere. The giant planets Jupiter and Saturn consist mostly of hydrogen. However, due to its high light nature, it is much less abundant, which is 0.15% by mass in the Earth's atmospheres. Of course, and the combined form, its constituent is 15.4% of the earth crust, and the oceans in the combined form. Besides in water, it occurs in plants and animals tissues. Carbohydrates, protein, hydrides include hydrocarbons and many other compounds. Now we talk about for the isotopes of hydrogen. So yes, we'll go for the same here. So isotopes of hydrogen, that we're gonna discuss the that what we'll be having here. So on the same way, respect towards this, we will be going to discuss isotopes So in terms of isotopes of hydrogen, where hydrogen has three isotopes. First is your protium, then other is your deuterium, and this is tritium. So that we have to discuss here in the detail. And so first we go for the same. So here the first one is your protium. One H1. The another one we have is your deuterium. Two H1 or D, and the another one is your tritium, 3H1 or T here. So that, can you guess how these isotopes differs from each other? These isotopes differs from one another in respect of the presence of neutrons. Ordinary in respect to the presence of neutrons. Hydrogen protium has no neutrons, and deuterium also have a heavy hydrogen and has one, and tritium has two neutrons in the nucleus. In the year 1934, American scientist Harold C. Urey got Nobel Prizes for separating the hydrogen isotopes of mass number 2 by a physical method, where the predominant forms of the protium terrestrial hydrogen contains 0.0156. So with the same we go for it, and that is in terms of in the year 1934, an American scientist Harold C. Urey got Nobel Prize for separating the hydrogen isotopes of mass number 2 by physical method. The predominant form is protium terrestrial hydrogen contains 0.0156% of deuterium, mostly in the form of Hd, and the tritium concentration is about 1 atom per 10 to the power 18 atoms of protium. Of these isotopes, only tritium is a radioactive and emits low energy beta particles, where T half is your 12.33 years here. Now in respect towards this, we'll have to discuss that since the isotopes have the same electronic configuration, they have almost the same chemical properties. The only difference is in their rates of reaction, mainly due to their different enthalpy of bond dissociation, which is however in physical properties. These isotopes differs considerably due to their large mass differences. Now we discuss the table, of course, but we'll discuss that in the next coming class, so that it will be helpful for you as well, and that is on the 10th classes we'll discuss that. And here in chemistry we had done your part 1, and we are continuing with the part 2, which is we had done unit 8, which is redox reaction, and we had started with unit 9, that is your hydrogen. Now other than this we talk about it. So yes, we had done your physics part 1. We had started for the NCERT solution, which has been the unit 1. We had completed the which is physical world, and the second one which we had started with units and measurement. We had done your reasoning, where we had completed the verbal reasoning and the non-verbal reasoning. Coming towards quantitative aptitude, yes, we had started with arithmetical ability, that is your we'll completing that in 15th topic we are on, and after completing that we'll discuss about the another one, which is the data interpretation, and we'll review CBNST, computer based numerical and statistical technique. In data based management system, we are dealing with the ER diagrams, and we are dealing with English vocabulary as well. And coming towards the chemistry for part 2, that we are talking here. Here we had started with the redox reaction. So yes, we had done that redox reaction. In redox reaction, before that we had done your chemistry part 1. In that, unit 1 is just some basic concepts of chemistry, unit 2 structures of atom, unit 3 classifications of elements and periodicity in the properties, unit 4 is your chemical bonding and molecular structure, unit 5 we had done your states of matter, unit 6 is your thermodynamics, unit 7 is your equilibrium, we had done. Now we had completed your unit 8 as well. That will be your classical idea of the redox reaction, oxidation and reduction reaction. Redox reaction in terms of the electronic transfer reaction, oxidation number, redox reactions, and the electrode processes as well. Unit 9 is your hydrogen, Unit 10 is your S block element, Unit 11 is your P block element, Unit 12 is your organic chemistry, some basic principles and technique, and Unit 13 is your hydrocarbons, and Unit 14 is your environmental chemistry. So we're gonna end up with thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion in the comment box. Thank you.